Okay, now what we have to do is set the diameter to 18 millimeters. So it's basically going to be looking like this. Because the second step is to scale it down. So it's not going to be a sphere anymore. So let's do that. We're going to have the diameter to 18. So for that we can just basically click here, 18. That's an ellipse. 18. Okay. And move it to the right position. Okay. And then it says to have it as to make it shorter by 5 millimeters. So for that we have to grab this point and type 5. Okay, let's see if we have the right position. I have to move it a little bit over here. Okay, I think we're good right now. Okay, and then move it to the target. Yeah, that's what we did. So every single time you have that orange shaded region is because that's the target. The next step is to drag a cone. So let's bring a cone up to here. And like so. Okay. Move that through and move like that. Okay, cool. We got it. Then select the height to be 28. So we just need to stretch that to be 28. And the next thing is the diameter is going to be 14. So let's do it from the top view. So 14 and 14. And let's place it again on the shaded region. So this is because the tutorial is going to give you that shaded region. If you're going to do your own project, you won't have that region, but you more or less know how to do it now. Okay, so the next step is to move the cone to the target area. So what we can do first is try to move it to this portion and then move it up. Okay, let's check other views to make sure that we're aligned properly. Rotate it, check that you're on the area, shaded area, and we are. So it says to lift it 3 millimeters, right? Basically use the arrow to do that. So you could have done 3 millimeters when you click on this arrow. It's going to ask you how much you want to move it. Okay, now we want to have another cone. And another cone. And that is because if we go to this image, now we're working on this inverted cone right here. This guy right here. Okay, so far we have this area. So let's go ahead and do practice our views, our positioning right here. We need to move up by 3. We need to put it right on the shaded region, and we did that. So let's go to the next step. Scale it to a diameter of 12. Okay, so if you notice, we have a diameter of 20, So let's go ahead and do a diameter of 12 and just click anywhere that is not the vertices, the points, and move it around. Okay, so we're doing good. Alright, so it needs to be higher, has to be a height of 19, or actually has to be a little smaller than that, 19. Okay, we're good. Let's do the next step. We have to rotate it 180 degrees, so full rotation. So when you click there, it's going to give you the option of 180 degrees, and that's what I want. So click outside, kind of like you do an AutoCAD, to accept, and then move it to the orange region. Alright, so this is where the views are very handy, because you use this guy to move up, and then you use the other views to make sure that you are right on the shaded region. Alright, we did the second step. Now we have to get another work plane on top, but I haven't been using the work planes very often. What I'm doing is I'm moving the parts and typing how much distance I want to have him at with respect to the base plane to the bottom plane. But anyway, let's do a work plane where by typing W, you go there and check that your plane is right. There you go. Now your plane has been moved to that place and it's pointing up. So remember that a plane has a normal, which is a perpendicular arrow telling you what direction the positive side of the plane is. That's a concept that you learn in linear algebra. For now, just know that this means that the plane is pointing up. So the X and Y are here, but Z is pointing up. If this little arrow then is pointing down, then X and Y will be on the plane. X and Y would be parallel to the plane, and Y and Z would be totally let's show you. Z would be aiming down, aiming to the bottom of the figure. But right now we have Z aiming up. And that's important because later when you want to do analysis of finite elements, all those figures have to have, they should have some positive plane, all the objects that we have. So the objects that we have are the cylinder, this cone, this sphere that now has a funny shape. Anyway, so all those objects need to have the same direction on a plane. If not, when you create your discretization in your mesh or your grid, you're probably going to have some issues. Okay, but we're not doing that. We're not doing finite element. We're not doing simulations. What we're doing is just a regular part. So we want to get another shape, another sphere on the plane. And we'll just get that. And what it's telling you is that the next step that we need to do is it's going to have 8 by 8 by 8. So it's going to be the same direction, the same distance everywhere. So it's still going to be a sphere. Alright, then we have that sphere. Now we just move sphere to this place, and since we're on the plane, then it's going to be the right height. I'm just going to make sure that is on the region that we want, which we have it there. Okay, then the next step is select all shapes and click the align button. But first we have to move the work plane to the bottom again. Okay, alright, good, we did that. So now we can select them all and we do align. And in this plane is where you make sure that you have a line like so. So if you click this point, it's going to move them over here. If you have this point, it's going to have an align with respect to this axis. Then you can rotate a little bit further, and then you can go align again with respect to this axis. Seems like we had him aligned pretty good. So we will need to fix too many things. But anyway, this is how you create this part. So here you can either export or send to. So OBJ, which is an object file that is for 3D printing, or STL, which is another file that you can use for 3D printing. For laser cutting, you have the SVG. Okay, or you can do a custom printer and then just send it directly to your printer, but you have to have a printer configured on your computer.